Hey everyone, in this video we're going to be talking all about lines. So lots of things to get through. We're going to hit all these objectives. So we're going to be talking about slope of a line first, and then if we're given a point and a slope, we want to graph the lines. We're going to find the equation of a vertical line, and then we're going to use a few different forms of a line. So we have actually a few different equations, if you want to think of it like that. We call them forms of a line, but we're going to use a point slope form, the slope-intercept form, and then general form. We're also going to use 2 points to graph the line. And then last, we'll talk about parallel and perpendicular lines. So all about lines in this video. Okay, so starting with slope. And so a staircase is a really good way to think about the slope of a line. If you think about how you would get from one step to the next, there's an amount that you run and then another amount that you rise. And so that rise over run is what we call the slope and the slope of the line. Okay, and so it's a ratio, and a lot of times we use the letter m for this. And so one way to remember this is that it's the ratio of rise over run. This is the definition of your slope, and like I just mentioned, a lot of times you will see this denoted as the letter M. For slope, we use that letter. So here is the definition, the formal definition. Given 2 points on the line. So the points, we're going to call them x1, y1, and x2, y2. Just 2 points on your line. And then as long as they're not the same exact point, then you're going to plug them into your formula right here, and you'll get the slope of the line. You'll get the number or the ratio that is the slope. And so what you want to recognize is that in this formula is you're finding the difference or distance between the vertical components of your points. So this is the rise part. Okay, so this is from one vertical point to the next, how much you're rising. And then over here, this is your x part. So this is the running, like horizontal movement. So how much you rise, the difference in the y's, over how much you run, the difference in the x's. And then we have this special note here. If you have a vertical line, the slope is actually undefined because you're only rising, you're not running, so the denominator would be 0. So it would be something like you'd get a number in your numerator, but you'd be dividing by 0, which is always undefined. So that's just a special case for vertical lines. Okay, so here's some pictures for us. On the left, this is a slope of a slanted line. On the right, it is a vertical line with an undefined slope. So in this case, it's just a visual for us finding this rate of change here. That's the ratio rise over run. So it's the difference in the y values. So there's some y value here, and then our next y value here. How much we rise from one y value to the next. And then here's the x values, one here and one here. And then how much we run. Rise over run, that's our slope. And then again, with vertical lines, it's undefined because you're only rising, you're not running left or right, and so there's a denominator of 0 there. Okay, so the slope of any non-vertical line is denoted m, and then this is our formula we just learned. So you want to have this memorized because it's going to help you find the slope pretty quickly if you just notice that it's the difference in the y's divided by the difference in the x's. But another way you see this noted is the change in y over the change in x, which is denoted with this Greek symbol delta. So we have delta y, which in math is going to stand for the change in something. So that stands for the change in y over delta x, which is the change in x. Alright, and so then we have that the slope is actually measuring the amount of change in the x's and the y's, and then we call this the average rate of change, specifically of y with respect to x. So the slope, it can be interpreted a few different ways. It's like we mentioned, the rise over run, change in y over the change in x. It's also representing the average rate of change. So I'm talking a lot about slope, and all of it is the same thing, but it's called different things. So average rate of change is exactly the same as the slope in this case. So a couple of things to talk about real quick, and then we'll get into some examples. So any 2 distinct points on a line can be used to find the slope. So it doesn't matter if it's a line which 2 points you pick, because it's not going to be curving or anything. So any 2 points you pick on the line will be perfectly fine for you to get the slope. So if your line is this, you could pick, let's just change the color real quick. You can pick this point, and it'll give you the slope. Or you can pick this point and this point. It's going to give you the same slope. Sometimes you'll have to simplify fractions, but it will end up being the same number every time, no matter what point you pick. And then the other thing to mention is that it doesn't matter if you pick 2 points, which way you plug them into your formula, as long as you're consistent. And so if you have point 1, we're calling it P, and point 2, we're calling it Q, as long as you're consistent. So in the original version of the formula, you say the second point coordinates minus the first point coordinates, so the 2's, y2 minus y1, x2 minus x1. But as long as you're consistent, you can switch it. So if you want to put the 1's first, so y1 minus y2 over x1 minus x2, then that's fine. But you don't want to swap them midway. So as long as the 2's are first in your formula, or the 1's are first in your formula, then you'll get the same number. And so here's just an image for you for why that's going to work. It's because you have these triangles that are going to have the same ratio here. Okay, so we're ready for this example. We're going to be finding the slope of a line given 2 points, and we're going to do it twice just to show you you're going to get the same answer no matter which way you do this. So let's say this is my first point, x1, y1, and then let's say this is my second point then, x2, y2. When I plug them into my slope formula, this is y2 minus y1, this is x2 minus x1, and notice my answer, oops, that's a 1 here, is negative 11/4. But I could do the same thing with just switching my points, and I'm going to get the same answer. So if I just said that this is going to be y1 minus y2, as long as I'm consistent and I pick x1 first on the bottom, then I have x2 being subtracted, I get the same answer. Okay, so just so you know, you can switch the points around and you will get the same slope. Okay, and this is basically just saying, for this example, for every 4-unit change in your horizontal movement in x, y is going to change by negative 11 units. Okay, so you could also think of it as x going up by 4, then y decreases by 11. So on this one, the average rate of change, another way to call our slope, average rate of change, slope, is negative 11/4. Okay, here's our next example. So we're going to compute the slopes of 4 different lines, and then we're going to graph them all. So 4 lines, one at a time. Notice on all the lines, the first point is the same, 1, 2, but on all the lines, the second point is different. So we're going to compute 4 different slopes here, and we're just going to label them slope 1, 2, 3, 4, so M with the subscripts. And then so our first line, y2 minus y1 over x2 minus x1 gives us 1 over negative 1, which is negative 1. The second line, the points we're plugging in, y2 minus y1 on top, x2 minus x1 on bottom. Negative 2 divided by negative 1 is positive 2. On the third one, y2 minus y1 on top, x2 minus x1 on bottom. 0 out of something is going to be 0. And on the last one, it's undefined, because when you plug this in, your denominator is going to be 1 minus 1. x2 was 1, but so was x1. And so your denominator is 0, and that's undefined. So we know actually that this is going to be a vertical line. So then let's go ahead and graph these. So here is all 4 of our lines. So line 1 had a negative slope. It's the one in pink. Let me just highlight this here, so we'll just point to it. So line 1 had a negative slope. It went through the point 0, 3, and then it drops down 1 and runs 1. So you drop 1 and run 1, drop and run, and then that's how you get that pink line. Line 2 had these 2 points on it, right? So you can just plot the 2 points and then draw a line through them, or you can use the slope. And we'll do another example where we use the slope. So we had the point 0, 0. It also had the point 1, comma 2. And then the slope was positive 2. Notice the line's going up to the right. So you could just plot the 2 points and draw a line through them, or you can think of it as the slope. You're going up 2, rising 2, and running 1. The third line was the one that's going to have a slope of 0. So notice that you're actually running, but you're not rising. So you're running, you have a slope of 0 because you're not rising. But then the last line, you're going just up. You're only rising. You're not running left or right. So that one had a slope that was undefined. Okay, so you want to kind of keep this in mind because it's helpful when you're graphing lines that anytime you have a positive slope, your line is always actually going to go up to the right. So that would be line 2 here. Anytime your slope is positive, your line's going to look like it's going up to the right. Anytime your slope is negative, that would be like line 1 here. It looks like your line is going down to the right. Okay, so up to the right, positive slope, down to the right, negative slope. And then slope of 0 is always, always, always a horizontal line. So anytime you see a slope of 0, it just means your line is horizontal. And then we talked about this last one. Your slope is undefined, so your line is vertical every time. Okay, so next example, we're going to draw a graph of the line that contains this point, 2, 1. So this is our x and our y. And then the given slopes. Okay, so this time we have 1 point and we have to use a slope to get to the next point on the line. So remembering that slope is rise over run, it tells us how much to rise and how much to run to get to the next point on our line. So we can draw the line through it. Okay, so we're going to start at the given point. That was 2, 1. And then we're going to move up 3 units and right 2 units. Or you can move right 2 and up 3. And then you have your ending point, which is 4, 4. Okay, so we started here at 2, 1. And then we rise from our slope. Remember, our slope was 3 halves. So we're going to rise 1, 2, 3. Okay, so if you need to, look at the y-axis here. So we rose 1, 2, 3, and then we're going to run 2 to the right. So 1, 2. We land right here. So again, look at the x-axis on this one. You run 2 to the right. And then you always run right, by the way, unless there's a negative, which we'll do an example so you see what I'm talking about. And then you have that point. And then once you have 2 points, you draw a line right through them, and then that's your line. Okay, so our slope here is negative. So what you can do is you can think of it as negative rise, which is actually a drop. And then I'll also talk about how you can think of it as a negative run, which would be running left. So if you have a negative slope, which we do have here, you can go ahead and put the minus sign up top and say, instead of rising, I'm really going to drop. I'm going to drop 5 units and then move 2 to the right. I'm going to run right. Okay, so we're going to start at 2, 1 again, and then we're going to go ahead and drop 5 and run 2 to the right. So here's our starting point, 2, 1, and then we'll drop, and let me go ahead and label the y-axis here. Okay, so we're going to drop 1, 2, 3, 4, 5, and then we're going to run 2 to the right, 1, 2, and then we land right at that point. Then we connect the 2 points and we get our line. Okay, and so I did just mention you could also, if you want to, think of it as moving left and rising. So that is one more way to think about this. Okay, so let's talk about it here. If you have a negative slope, you can put the negative on the bottom, and what that does is it changes your running. Instead of running right, we usually always run right. Okay, we always usually run right, but if it's a negative slope, you can think of it as running left. Okay, but then because you put the negative down on the denominator, you're going to rise 5. So you're going to rise 5 and run 2 to the left. You will get the same line, but it's just another way to travel. So let me draw it really quick, and then we will hopefully make this pretty clear. So here we go. I am going to plot my points. I'm just put some tick marks. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 1, 2. Okay, just a few for us. All right, let's go ahead and plot our points. So our initial point was 2, 1. And then we are going to this time run 2 to the left. So we're going to run 1, 2 to the left, which is here. And then we're going to rise 5. 1, 2, 3, 4, 5. And then what you would see is we would actually get the same exact line that we got from dropping 5 and running 2 to the right, which put us down here. Okay, so you can do this either way. Anytime you have a negative slope, you have an option. You can put the negative on the top, or you can put the negative on the bottom. Just pick one, it's up to you. The negative on top means you're dropping and running right. The negative on bottom means you're rising but running left. Okay, so example, we're going to graph this equation of this line. What does this look like? It just says x equals 2. How do we graph that? So to graph this, we're just finding all of the points on the xy plane where x equals 2. And if you think about it, this is all that has to be true. So all I'm told is x equals 2. It might seem like that's not a lot of information, but it's actually plenty of information because that's all that has to be true. So y can be anything. Y can be any number as long as x is 2. And so what that graph ends up looking like is that it's just going to be a vertical line. So x is 2 right here on the x-axis, but it's also 2 right here. This is x equals 2, x equals 2, x equals 2, x equals 2, all the way forever in both directions, up and down. Y can be 0, y can be 1, y can be 2, and so on, but x is 2, and so this is a vertical line. And remember, vertical lines, the slope is undefined. So this brings us to our equation of a vertical line. So anytime you are given the equation x equals a number, so a is a number, it's going to be the x-intercept on your graph. But anytime x equals a number, this is going to be a vertical line every single time. Alright, so now what we're going to get into next is our first form of a line, equation of a line, that is the point slope form. So remember, we talked about at the very beginning of the video, we were going to look at 3 different forms of a line. So this is our first one, the point slope form of a line. So this is an equation of a line, and so I want you to make sense of this. This is an equation of a line, and it's specifically the point slope form of an equation of a line, because we're going to learn 3 different ways to write the equation of a line. This is way number 1. So what this says, and every equation of a line has a y in it and an x in it, okay, after you're done simplifying. So what this says is if I have a point x1, y1, I'm going to plug that in. Let me change colors. I'm going to plug that point that I'm given in right here, after the minus sign here, and after the minus sign here. I'm also going to plug in a slope right here, and then that is my equation of a line. So I have to know 2 points on my line. Think about it, if you have a line, you do need to know 2 points so that you can find the slope between them and then draw the line through them. Okay, so let's do this example. So we have to find the point slope form of an equation of a line. The slope is 3, so slope is 3, that means m is 3, and then the point on the line is 1, 0, so that's x1 and that's y1. Okay, so we have all of our information that we need. We have m, x1, and y1. And then all we're going to do is we're going to plug right into our equation of a line. So this is what we know. We just learned this. So we're plugging in right here, and right here. So y1 was 0, x1 was 1, and m was 3. And then once we've simplified, so notice y minus 0 is just y, and then if you distribute the 3, you get 3x minus 3. Final answer. This is our line. We used the point slope form and simplified to get to this equation of a line. Okay, so here is the graph of that equation. So we have 1, 0, and then we can use a slope of 3 to get another point. So we can go up 1, 2, 3, and run once to the right and get that other point on the line. Okay, and then that is the graph of our equation we just found. All right, next example. Find an equation of a horizontal line, and then this is the point on the line. X1 is 2, Y1 is 3. Remember, what do we know about horizontal lines? Well, we know every single horizontal line, the slope is always 0. Okay, so m is 0. We have 1 point on the line, so we're going to plug in m is 0, x1 is 2, y1 is 3. Right into our formula. So again, this is our formula, and then we plug in y1, we plug in m, and we plug in x1. Simplify, and we get y equals 3. And that is the answer. And it looks like pretty simple, but y equals 3 is the equation of this horizontal line. And so this is what it looks like. So 2, 3 is our point, and then because it's a horizontal line, we just draw it horizontal, and you could plot the y-intercept if you'd like at 0, 3. And anytime you see y equals a number, brings us to our next point, it's a horizontal line. So we talked about the equation of a vertical line. Now, anytime you have a horizontal line, it's always y equals a number. So in this case, y is the, b is the y-intercept. But in general, anytime y equals a number, always, 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 this is a horizontal line. Okay, so now we are ready for version 2 of an equation of a line. So again, hopefully I'm making this clear. We were going to talk about a total of 3 different equations of a line, like 3 forms. This is form number 2. So this is the slope-intercept form. The last one was called point-slope form. So this one's called slope-intercept form. And this is what it looks like. And this might be the most familiar one. A lot of people tend to remember this one. So y equals mx plus b, where m is the slope and b comes from the y-intercept. Okay, so jumping right into an example, find the slope and the y-intercept of this equation and then graph it. So notice this equation is not in slope-intercept form, but if we can write it in slope-intercept form, we can answer this question. So we're going to solve for y, because slope-intercept form, we just learned it, it's y equals mx plus b. So if we solve for y, we can match up what m should be and what b is. So take your equation, start solving for y. So we'll say subtract 2x from both sides because I'm trying to solve for y. Okay, and then I have 3y equals negative 2x plus 6. And then solving for y, so I'll divide everything by 3. And then so y equals negative 2/3 x plus 2. And so now I can tell just by looking, let me change the color here, that this number multiplying x, this is my slope. So this number right here, multiplying x, is my slope. And then the number in the back, let's go ahead and change the color on that one too. The number in the back here, b, is my y-intercept. So positive 2, 0, 2 would be my y-intercept. Now that I have my equation in slope-intercept form, so slope-intercept form, I can tell just by looking what is the slope and what is the y-intercept. Okay, so putting that in my graph, my y-intercept was 0, 2, so I plot that point. And then I can use my slope to get another point, so I can graph the line. So because our slope is negative 2/3, you have a choice. Remember, you could say negative 2/3 or 2 over negative 3, and you will get the same graph. I'm going to go ahead and pick the first one. So from my point 0, 2, I'm going to drop 1, 2, and I'm going to run 3 to the right. Run, 2, 3. And I'll plot that point right there. Okay, and connect them, and then that is the equation of our line. Okay, so just explaining what we did to get our point here. All right, next example. Find an equation of a line containing these 2 points. Okay, so we're given 2 points, and then graph the line. What I want you to notice, and this is really important, you are not given a slope. So notice we weren't given a slope. So we always want to know with a line, if we're asked to find the equation of a line, what is the slope? Find the equation of a line, I have to know the slope. I have to know this, okay? So I'm given 2 points. Well, we know a formula for this. We learned a formula at the beginning for finding the slope between 2 points. Let me write it down again. We've did it before, but it's y2 minus y1 over x2 minus x1. All right, so now that we have to recognize that. So notice the problem didn't say, hey, find the slope and then do this. The problem just said, find the equation of a line. Okay, so we have to recognize that we need the slope. And so this is something we'd have to go back in our notes and say, oh yeah, the slope formula is this, and hopefully eventually you memorize it. And then our first point we can go ahead and say is 3, 2, and our second point is negative 3, 4. And we just plug those into our formula. So 4 minus 2 on top, negative 3 minus 3 on bottom. 2 over negative 6 simplifies as negative 1/3. Okay, just divide the top and bottom by 2. Okay, so using our slope formula there. So we now have the slope. We know m. We also know 2 points on the line. We actually only need 1 if we want to find the equation and the slope. Okay, so we have one of the points to graph, and then the slope also, and then we'll use that to get the equation. So notice we have the point 3, 2, and so on this one, again, if your slope is negative, you could say negative 1 over 3, or you can say 1 over negative 3. This time we're going to go ahead and pick the second version. We're going to rise 1 and run 3 to the left. 1, 2, 3. And then plot that point and then connect it to get our line. Okay. Or you could have started here at negative 3, 4 and then dropped 1 and ran 3 to get the same line. Okay, but what we also have to do, because part of the question said graph this, the other part said find the equation. So notice what we're using. We are using the point slope form to get the final answer. Now let me make this clear, because this is actually pretty important. It is very useful to use the point slope form to get to the slope-intercept form. So we learned both of these so far, and sometimes you can just jump right into the slope-intercept form if you want. That's okay. But a lot of times it's easier to start here. So start with the point slope form, plug into it. Okay, I'm going to circle everywhere we plug in, because we plug in for y1, we plug in for x1, we also plug in the slope of m. So we plug in y1 is 2, x1 is 3, slope is negative 1/3, and we simplify. And then after we simplify, then we have our slope-intercept form. So it's usually a lot easier to start here and then simplify to get to the slope-intercept form. So in this one, just real quick, you simplify by distributing negative 1/3, and then if you add 2 to both sides, that's where that 3 plus 3 came from. Okay, so next we're going to talk about the third and final form of an equation of a line, and it is called general form. Some books call it standard form. And so real quick, just to remind you, we talked about point slope form, we talked about slope-intercept form, and now this is the third one. general form. So it looks like ax plus by equals c. And most of the time, it doesn't explicitly say this, but most of the time what you're going to see is that a, b, and c are integers. So not just real numbers, but a lot of times you'll see these as integers, meaning that they're not going to be, like, it's not going to look like fractions. Okay, so if you have fractions, you can just multiply by the common denominator between them, and then you'll turn those into integers. Okay, so let's do this example. Graph this equation by finding its intercepts. Notice that this is in general form. We have ax, where a is 2, plus by, where b is 3, equals c, where c is 6. Okay, so as you recall, hopefully from the previous time we talked about intercepts in another video, if you want to find the x-intercept, you let y equal 0. So y equals 0. If you want to find the y-intercept, you let x equal 0, because you're on the the y-axis, so x is 0. Over here you're on the x-axis, so y is 0. Okay, so we're going to start with the x-intercept, letting y equal 0. So exactly where there's a y, just plug in 0 using parentheses, and then you end up with 2x equals 6. Divide both sides by 2, and you get x is 3. So then the point on the graph, your x-intercept would be x is 3 when y is 0. Okay, so that's the point that is the x-intercept. Then to find the y-intercept, let x equal 0. So exactly where there's an x in your equation, put a 0, simplify, and then in this case we'll divide by 3, and so y is 2. And so when x was 0, y was 2. And so then we have 2 points on the graph. As long as we have 2 points, we can draw the line between them, and then that is the graph of our equation. Okay, so notice there is our y-intercept, here is our x-intercept, and then we just draw the line between them, and that is the graph of our equation. Alright, the last thing we're going to be talking about, we talked a whole lot about different things with lines and equations of lines. The last thing is parallel and perpendicular lines. So starting with parallel. When two lines don't intersect at all ever, the only way that's going to happen is if they're parallel. So they have, notice, the same rate of change or the same slope. So they rise the same amount and then they run the same amount. So every time one line goes up and over to get to the next point, the other line does the same thing. Sort of like, think of like a ladder. So a ladder has parallel sides. So like, just pretend this is a very good drawing of a ladder. The sides of that would be parallel. And so we have a theorem for this. This is our criteria for parallel lines. Two non-vertical lines are parallel if and only if their slopes are equal. So, and they have different y-intercepts. So pretty much you're looking for the same slope. So are the slopes the same? Then your lines are parallel. This extra part about different y-intercepts is just so you know that you don't have the same exact line. If you have the same slope and the same y-intercept, well then it's just a single line being repeated. So these statements here are just sort of the reverse of each other. If two non-vertical lines are parallel, then they have the same slopes and different y-intercepts. And opposite, if two non-vertical lines have the same slope and different y-intercepts, then they're parallel. So it's just saying two directions. So parallel implies same slope, different y-intercept. So y-intercept is different. And then the second statement just says the opposite, so it's saying to the left. Slope and y-intercept are different. Slope same, y-intercept different, means parallel. Okay, so here's an example. Show that two lines are parallel. So we can show by graphing, but we can also show by just noticing that they have the same slope. So notice it doesn't say exactly what to do. It doesn't say, hey, show that these have the same slope. It just says show that they're parallel. So show that they have the same slope and that they have different y-intercepts. So parallel, the thing I want to think of when I read that on a question is I want to think same, not same parallel, I want to think same slope. Let me just fix that really quick. So keep that in mind. Every time you see parallel lines or you read about them, just think to yourself, same slope. Okay, so we want to see if the slopes are the same but the y-intercepts are different. So the best thing to do is to put this in slope-intercept form. And just a reminder, that looks like y equals mx plus b. If we can rewrite our equations in this slope-intercept form, we can tell by looking what the slope is and what the y-intercept is. So that's why we want to pick this form out of our three forms. So all we had to do on this one was subtract x from both sides and then divide by 2 on every term. And so y equals negative 1/2 x plus 3. So the slope is negative 1/2 and the y-intercept is 3, or you could say 0, 3. Second line, same process. You're going to subtract 2x from both sides to get this in slope-intercept form. Divide both sides by 4. And then notice we have y equals negative 1/2 x plus 0. There's an invisible 0 back here. So the slopes are the same and the y-intercepts are different. So using algebra, not using any graphing, like we didn't look at the pictures of the lines, we could tell that these are going to be parallel because the slopes are the same, meaning that the rate of change, or rising and running, is the same rate on both lines, but we start at different points. The y-intercepts are different. So then the lines are actually different lines, but they're parallel lines. And here's what they look like. So one line had a y-intercept of 3, 0, 3. The slope was negative 1/2, so we go down 1 and run 2 to the right. The other line had a y-intercept of 0, 0, so we go down 1 and run 2 to the right. And so every time we drop 1 and run 2 to the right, we have these parallel lines that we create. All right, next example. Find a line that is parallel to a given line. So we want to find an equation for the line that contains the point 1, 0 and is parallel to the line given here. Okay, so you have to think a little bit about this, about how to solve this. We're asked to find an equation of a line. We have lots of forms for an equation of a line, 3 forms. And I'm going to write them down, and then we're going to pick which one would be the easiest for us to use. And I mentioned this earlier in another example, but hopefully you remember. But I'm going to write it down and then we'll review. Okay, so here are our 3 equations for lines, the 3 forms: point slope, slope-intercept, and general or standard form. Now the directions just say find an equation for the line. So you have to pick out of these 3 which one you're going to use. And I mentioned this in another example, but usually it will be easiest to use point slope. So we're going to pick point slope form. We have 3 options, but we are picking this one because it's usually the easiest to use. And it's because you plug in a point and you plug in a slope. Okay, so we have number 1, we picked our point slope form. So we're going to use that. So I'm going to write down what we are doing so far because we're doing this in steps. This problem doesn't say exactly what to do. It doesn't say, hey, use this form of an equation of a line and then do this and do that. We have to figure this out. It's more of a problem-solving type of problem. Okay, so we have this part, step 1 down. Step 2 is to recognize that you have a point. So we're going to fill in x1 and y1 with the 1 and the 0. But what we don't know is the slope. We need the slope. So my question is, what is the slope? Okay, so we're given some information here that the line we want is parallel to this given line. So that is how we're going to find the slope. So let's go ahead and start with what we know for the point really quick. y1 is 0, x1 is 1. So I'm just going to fill those in. Let me go ahead and go back to green. This is y minus 0 equals m times x minus 1. Okay, what I need now is m. We need the slope, and we're told that it's parallel to this equation here, this line. So what you have to do is you have to say, well, what's the slope of this line? Well, if I put it in slope-intercept form, then I can find the slope of this line. So we're going to go to slope-intercept form, and I have it written above, but it's y equals mx plus b. So you're just solving for y to make it look like this. Okay. Okay, so I'm going to subtract x from both sides. So I have 2y on the left, and then I subtracted x, so minus x plus 6 on the right. I subtracted x from both sides up here. So let me just write that, minus x minus x. Then I'm going to divide everything by 2. So I have y on the left, negative 1/2 x, and then plus 3. Okay, so I divided everything by 2. That's where the negative 1/2 came from, and then the 6 divided by 2 is 3. So the point of this was to see that this right here is my slope. And because this is the slope of a parallel line, it means I want the same slope. So we want the same slope. And that's because it's parallel, because of this word right here. Okay, so now we can plug that in. We know that where we have an m, we're going to put a negative 1/2 right in that spot. Okay, so we have everything else was already there. Y minus, I'll just keep it there, 0, even though you don't really need to keep writing 0 there. And then m was negative 1/2. This is x minus 1. And then you simplify. So from here, we're almost done. We're just going to simplify this, and that will be our answer. So the point of this question, it was more of a problem-solving type question. We had to figure out how do we answer this. We had to first decide which form of our line we're going to use, 1, 2, or 3 here. We picked number 1. Then we had to recognize we had a point given, and that parallel to another line means we wanted the same slope. Okay, so I think I have that all typed up here. So let me go ahead and hopefully you can see it behind all my scribbling. So because the two lines are parallel, the slope we want is the same as the slope of that line. And then we put it in slope-intercept form and figured out the slope was negative 1/2. Okay, and then we use the point and the slope, plugging into our point-slope form of a line, simplify, and then this would be the slope-intercept form. So what I want you to notice is that there's more than one way to write the answer. So this is the answer in slope-intercept form. But let's say you were asked to find the answer in general form, then this is the answer in general form, or standard form. Okay, and so notice if you want to go from slope-intercept to general form, what you want to do is you want to bring the x's to the other side. So what I would do first is I would add 1/2 x to both sides. And so let me put this intermediate step. It would look like 1/2 x plus y on the left equals 1/2 on the right. And then remember I mentioned that these should be integers. So then you would just multiply both sides of this equation by 2. Okay, and the 2's are going to distribute here. And so that's where you end up with this last one. So it'd be 2/2, which is just 1, so x, and then 2 times y, and then 2/2 on the right, which is just 1. And that's where this came from right here, general form. All right, so then here is the graph of this line that we just found. So x plus 2y equals 1, parallel to our other line, but it goes through this point, 1, 0. So you can use the point, and then we can use the slope to graph this line. Remember the slope was negative 1/2, so drop 1 and run 2, and then you get that 2 points on the line and connect them. All right, last thing, very last thing. We talked about a whole lot of things with lines, perpendicular lines. So parallel lines was one thing. Perpendicular are two lines that intersect specifically at a right angle. So they pretty much look like a cross or a plus sign when they intersect. So they have to meet at a right angle. That's what makes them perpendicular. Just so you know, orthogonal is another word here that you might hear, especially in the future if you keep going in math. Orthogonal is the same as perpendicular. Okay, so the criterion for perpendicular lines, the two non-vertical lines are perpendicular if and only if, when you multiply them, that's what product means, their slopes are -1. Okay, so a lot of times people actually remember this as a negative reciprocal of the other slope. Okay, so that might Be another way to think of it for you. So if two non-vertical lines are perpendicular, their product of their slopes is -1. And if two non-vertical lines have slopes whose product is -1, then they're perpendicular. So this is the whole if and only if part. If they're perpendicular, then their slopes are -1 when you multiply, and then vice versa. If their slopes multiply to -1, then they're perpendicular. Okay, so these are just the same sentence, just broken into two parts as the original sentence. The other way to think about it, and I said it out loud, but a lot of people remember it like this. So they'll say one slope is the negative reciprocal of the other slope. So negative reciprocal. So if I had, for example, a slope of 3/2 for one of my lines, we'll call that slope 1, then the perpendicular slope, and this is a symbol for perpendicular right here, so the perpendicular slope would be the reciprocal, which is 2/3, but negative. Okay, that's one example. Another example would be if my slope, let's say my first slope was -4. Okay, let's say -4. Okay, if I flip over from -4, it becomes 1/4, and then the negative of that is going to turn positive. So the original was negative, so if I put a negative on there, this turns positive. Okay, so these are perpendicular slopes, -4 and 1/4. And it makes sense, if I multiply them, my answer is -1. So another way to remember this is that the slopes are negative reciprocals of each other. And then another thing that helps me always remember, one of the slopes is always negative, while the other one's always positive. So here's just a quick example, kind of like we just did. If a line has slope -1/2, then any line having slope of 2 is perpendicular to it. Because if you flip over 1/2, that becomes 2/1. It's already negative to start with, so when you apply the negative sign, then you get +2. Okay, so the negative reciprocal of -1/2 is 2. Or if you want to multiply these, -1/2 times 2 is -1. Either way, this fits the criteria for being a perpendicular line, or two lines that are perpendicular. So last example, find an equation of a line that contains the given point and perpendicular to this line. Graph the two lines. Okay, so we just did an example where we were finding an equation of a line, but it was parallel. So very similar process. We have to choose which form of the line we're going to use, form of the equation. We're going to plug in this point, x1, y1, and then we're going to have to use the fact that if we're looking at a perpendicular line, we need to find the slope of this line, but then we have to flip it over and put a negative, so we need to find the negative reciprocal of that slope. Okay, so first we're going to write the given equation in slope-intercept form to find its slope. So we're starting with the slope. So we are trying to answer at this moment, what is the slope that we need? Okay, so if you start by subtracting x from both sides and then divide by 2, we're going to get that this slope is -1/2, but we don't want -1/2. So even though the slope is -1/2, we're not looking for a parallel line. We don't want -1/2 as our slope. We need to flip that and put a negative sign on it. So because the given slope was -1/2, the one we want, the perpendicular slope, is the negative reciprocal of that. So one more time. This is the slope we were, oops, not 3. This is the slope of the line we were given, but this is perpendicular to what we want. So the slope we want, flip this over, 2/1, and always add a negative, so if it's already negative, it turns positive. So that's why our slope should be 2. Now we have everything we need. We have a point on the line, we have the slope of the line, and then we're just going to plug into our form, point slope form. So plug in y1, m, and x1, simplify, And then we'll get that this is either in slope-intercept form, y equals 2x minus 4, or general form, 2x minus y equals 4. Okay, so real quick to get to general form here, if you subtract 2x from both sides, you'll get negative 2x plus y equals negative 4. And you can leave that, but it's usually standard practice to make the x positive, so we just divide everything by negative 1. Sorry, this looks pretty sloppy, but that's where this came from, general form. And then here is the two graphs, and they should look like they meet at a right angle, the original and then the one that we found. Okay, because if they don't, then they're not perpendicular and something went wrong. And so this had our point, 1, negative 2, and then the slope of 2. So rise 1, 2, and then run 1. Okay, there it is. Very long video about lines, but hopefully it was thorough enough for you to feel okay about them, and we learned like everything we can learn about them at this point. So we learned a whole lot about lines. So feel free to go back through and review the different parts, but the main thing is to remember how to find the equation of a line, because that's one of the things that you'll do most often. All right, take care. Thank you for watching.